Electric circuits, although very useful, can also be hazardous. To reduce the danger inherent in using circuits, proper electrical grounding is necessary. The connection to ground in a circuit is shown here and is called ground because that is where the path usually leads, literally into a copper post embedded in the earth. The earth is considered to be an infinite source and sink of charge, and we can dump as much electrical current into it as we like. The figure shows a clothes dryer connected to a wall socket via a two-prong plug. When the dryer is operating normally, the wires inside are insulated from the metal casing of the dryer, so no charge flows through the casing itself. Notice that one terminal of the AC generator is customarily connected to ground by the electric power company. A potential hazard can come into play with a two-prong circuit where a wire comes loose and makes contact with the metal casing. A person touching the casing could receive a shock, since electric charge can follow a path through the casing, the person's body, and the ground on the way back to the generator. Note that the current will take the path of least resistance back to the generator, and this may be through someone touching the casing if the person is grounded. As it happens much too often, serious and sometimes fatal injuries can result from electrical shock. The severity of the injury depends on the magnitude of the current and the parts of the body through which the moving charges pass. The amount of current that causes a mild tingling sensation is about 1/1000th of an amp. Currents on the order of 1/100th of an amp can lead to muscle spasms in which a person can't let go of the object causing the shock. Currents of approximately 0.2 amps and greater are potentially fatal because they can make the heart fibrillate or beat in an uncontrolled manner. Substantially larger currents stop the heart completely. However, since the heart often begins beating normally again after the current ceases, the larger currents can sometimes be less dangerous than the smaller ones that cause fibrillation. There are ways of safeguarding against shocks that occur due to an internal short inside of a device. Here we show the same clothes dryer connected to a wall socket via a three-prong plug that provides safe electrical grounding. The third prong connects the metal casing directly to a copper rod driven into the ground or to a copper water pipe that is in the ground. This arrangement protects against electrical shock in the event that a broken wire touches the metal casing. In this event, charge would flow through the casing, through the third prong, and into ground, returning eventually to the generator. No charge would flow through the person's body because the copper rod provides much less electrical resistance than does the body. With this in mind, it is ill-advised to remove the third prong from a device in order to plug it into a two-prong plug. It is better to buy a properly grounded, three-pronged adapter.